couple more things, which are polyatomics. Poly means many. Atomic means atom. So these are more than one atom. Ion means charged particle. So basically what it was a couple of atoms that for some reason most of them have gained electrons and became charged. So these are common polyatomics, and it says to memorize. I've got 15 of them. I used to make my students learn 25, but I've narrowed it down to 15. And I've got parentheses around them, so you might want to start doing flashcards to help you remember these. This has been uploaded for you. The top 15 are the ones you need to know, and then there's 5 or 6 others that we're going to use that you don't have to memorize. And then all else failed, if on Chem 101 you don't recognize them, I think you could just Google them. There's hundreds and hundreds of polyatomics, but I picked 15 of the most common ones. I do want to point out while we've got this on there, those are L's. I'm just in Times New Roman, and the students think that is an I. That is ClO4, ClO3, ClO2, and ClO1 technically. So you kind of learn those as a foursome there. But those are L's. ClO4s. Notice their charges. So most of these guys have a 1- charge. You've got a few that are a 2- charge. One of them that is a 3- charge, and one of them is a cation, which is ammonium. So I would like you to memorize these for your test. Memorize for your test. Okay. All right. I'm going to show you how these work. And again, you could print these off. We're going to do a couple of examples. Notice their endings. Most of them have a T in there. There's a couple that are IDEs, but most of them have a T in there. That's how you can recognize that you're dealing with a poly. They're either an ate or an ite. You're going to memorize a couple of the IDEs, which is cyanide. You've heard of cyanide. It's kind of poisonous. Hydroxide. Hydroxide has hydrogen and oxygen in it. Hydroxide, very common polyatomic. So that's how you recognize. See that IDE or ATE or ITE. So what does the Roman numeral mean again? The Roman numeral is the charge of the atom. So this is a +2. If I look up nitrate on the ATE, you're not going to find them on the periodic table. Its periodic table would be the IDE ending. So ATE means it's a poly. So it's a 1-. So this is how this works. So this copper is a 2+. I am going to do the swap drop method on this. So that's a 2+. And I'm going to put brackets around my poly. That whole thing is carrying a 1- charge. I tell my high schoolers that that bracket is like a force field. You're not allowed to go in there. You can only work around the bracket, because that whole thing is a unit, and you can only work around the unit. So just like we did with the ionic compounds, I'm going to take this number and I'm going to move it, but I can't go inside the bracket. I got to go outside the bracket. So it's going to go all the way there, and that 1 is going to go down there. So I'm still swap dropping. So now it looks like this. CU1. Ones don't need to be written. Parentheses NO3, close the parenthesis 2. So CU parentheses NO3 2. 1 does not need to be there. If it makes you feel comfortable, write the 1. That is called copper 2 nitrate. Copper 2 nitrate. So now I have copper 1 nitrite. I want to show you this one. So now I've switched I could have copper 1 nitrate as well, but I wanted to show you this. So this is a +1. Okay. If I look on the periodic table, nitrite, you'll notice is, if you learn the ATE, the ITE is 1 less oxygen. So I would learn them in pairs. I'd learn nitrate, nitrite, sulfate, sulfite, chlorate, chloride. It's 1 less oxygen. Same charge. Okay, same charge. So ITE, NO2. So if I memorize those, this makes this a lot easier. So if it's a +1 and a -1, remember they cancel each other out. And so it's just going to be CuNO3. Because there's not a number I'm going to put the parentheses. It'd be a 1 and 1. Because these are going to be 1s, and not, see, this 2 is going to distribute when we start counting atoms later. Because this is a 1, that parentheses can actually disappear. And so you could write it like this, CuNO3. If you'd like to keep the parentheses around your polys, feel free to do it. Can you see this one? It doesn't have parentheses because there's an understood 1 there. So if it's an understood 1, the parentheses actually disappear, so you won't see the parentheses on polys. But poly means more than one atom. So as you're looking at a formula and you see a bunch more than 2 atoms, you know that there's a poly involved. Okay? So let me do some erasing here. Okay. Let me get this guy up there. So aluminum sulfate. Aluminum is a 3 positive. Sulfate is a 2 minus. I'd look on the sheet until I memorize it. And so aluminum, 3 positive. Sulfate, 2 minus. And we're going to switch them. That's going to go there. That's going to go there. Al2SO4, 3. That's the formula. Remember, the positive and negative go away when you're finding the subscripts. All right, calcium. Ca is a positive 2. Sulfite, can you guess? 1 less oxygen, same charge, so it's SO3. It's got a 2 minus charge. What happens when they're the same charges? When they're the same charges, they cancel each other out, so it just becomes CaSO3. You can keep the parentheses if you want, but it's not necessary. Okay, CaSO3. All right. Now we move on. How am I going to know that's got a poly? Well, I know it's got a poly because it's more than 2 elements. Okay, usually it's a metal and then a poly. A metal, then a poly. We'll get down to that one in a second. Because if you'll notice on that sheet, they're all anions. Remember, the non-metals were the anions, so they're always going to be on the end. So your polys most of the time are on the end part. And if you start memorizing it, then you'll know. To name a poly, you just write the name of your metal, just like before, and then you just write the name of your poly. You don't change it unless it's an acid, and that's a different lesson. So this is acetate, a lithium acetate. I'm just going to write acetate. We write, most of the time, write it this way, but some of you may move on to organic. Acetate can also be written this way. So in organic, you'll see it as Chaku looking thing. So I just want to bring that out. If you take organic, you may see it. We're going to go ahead and write it as C2H3O2, but some of you may see it as Chaku. But either one's correct. So lithium acetate. Well, that is zinc. Zinc doesn't need a Roman numeral because it's always a 2. And then PO4 is phosphate. See, the numbers have already been switched for us. All right. So I wanted to do this guy because that is, those of you who are going to take a lab, is a poly that we're going to use in the lab. And it's the only cation. There are other cations, but it's the only cation that I'm making you learn. And that is ammonium. It is a positive 1 charge. It doesn't have parentheses because it's a 1 and a 1 there. So this is ammonium, and it shows up in the beginning. So this is ammonium, not ammonia, but ammonium. And then this is the element chlorine, but it's in a bond. So we would still change it to IDE because it's off the periodic table. So this is ammonium chloride. Ammonium chloride, and we deal with that in lab. Okay. Well, as you start to get more comfortable, that's a poly, but that one also is a poly. So these are 2 polys, so neither one of them are going to change their names. This is ammonium, positive 1, negative 1, both of them are, and that is hydroxide, ammonium hydroxide. And that's just the name of that poly, hydroxide. Very common poly. All right. So we went over ionic compounds. We went over how to predict an oxidation number. We've learned how to write a configuration for an ion, and we learned how to write the formula for an ionic compound, and we learned to write the formula to name it, and then we learned to deal with polyatomics. So you have some of these on Chem 101, but also I've put up some of the old homework that you could practice on to get good at it, and I have put up those answers as well. So I would think the more practice, this is something that we'll use over and over and over and over again in chemistry, so you might, especially ionic, so you might as well go ahead and try to get good at writing formulas and naming them. Have a great day.